Have you ever felt lost in a sea of data, unsure how to make sense of it all? You're not alone. We've all been there, staring at spreadsheets and wondering where to even begin. But just like we use telescopes to explore the cosmos, we use statistical tools to navigate the vast universe of information. Choosing the right statistical tool can be overwhelming, but don't worry. In this video, I'll break it down into simple steps so you can analyze your data with confidence. Get ready to learn what statistical tools are, how to match them with your research design, and even see examples of common statistical tests. So you've got this mountain of data staring you in the face. Where do you even begin? Well, every scientific journey, whether it's exploring the cosmos or analyzing data, starts with a fundamental question. What is it that you really want to know? Think of your research question as your North Star, guiding you through the data analysis process. Are you trying to compare different groups? For example, maybe you want to see if there's a difference in test scores between students who study with classical music and those who don't. Or perhaps you're on the hunt for relationships between variables. Is there a link between hours of sleep and productivity at work? These are the kinds of questions that will shape your entire analysis. Defining your research question is crucial because it determines the types of statistical tools you'll need. It's like choosing the right spaceship for your mission. You wouldn't take a rocket designed for a lunar landing on a voyage to Mars, would you? Take some time to really think about your research question. Write it down, refine it, make sure it's clear, concise, and focused. This will be the bedrock of your entire analysis. Remember, a well-defined research question is the compass that points you in the right direction. Without it, you're just wandering aimlessly through a sea of data. Now let's consider a few examples. Let's say you're researching the effectiveness of a new drug. Your research question might be, does the new drug lead to a greater reduction in blood pressure compared to a placebo? Or, imagine you're investigating consumer behavior. Now that you've defined your research question, it's time to put on your detective hat and examine the clues, your data. Just like a detective analyzes fingerprints, handwriting, or DNA, we need to understand the nature of our data to choose the right tools. In the world of statistics, data isn't just numbers and figures. It's categorized into different types, each with its own quirks and characteristics. Think of it like sorting astronomical objects. You wouldn't analyze a star the same way you would a black hole, right? One fundamental distinction is between categorical and numerical data. Categorical data, as the name suggests, deals with categories or groups. For instance, if you're studying different species of birds, the species would be categorical data. Other examples include gender, hair color, or types of cars. Numerical data, on the other hand, deals with, well, numbers. This type is further divided into discrete and continuous data. Discrete data takes on specific values, usually whole numbers. Think of the number of planets in a solar system or the number of students in a classroom. Continuous data can take on any value within a range. Examples include height, weight, temperature, or time. Understanding your data type is crucial because it significantly influences the statistical tools you can use. Imagine trying to calculate the average color of a group of cars. It just doesn't make sense. Similarly, using a statistical test designed for numerical data on categorical data would lead to misleading results. So, put on your detective hat, examine those data points, and get ready to unlock the secrets hidden within. We've identified our research question, categorized our data, and now we're ready to select the perfect tool from our statistical toolbox. It's like a chef choosing the right knife for each ingredient, a paring knife for delicate herbs, a chef's knife for chopping vegetables, and a serrated knife for slicing bread. But with so many statistical tests out there, how do we choose the right one? Well, just like a good chef knows their knives, we need to understand the strengths and weaknesses of each statistical tool. Let's start with a simple scenario, comparing two groups. Suppose you want to know if there's a difference in average height between men and women. In this case, you'd reach for the trusty t-test, a statistical workhorse designed to compare means. Now imagine you have more than two groups. Let's say you're comparing the effectiveness of 3 different types of fertilizer on plant growth. In this case, you'd upgrade to ANOVA, or analysis of variance, which can handle multiple group comparisons. But what if you're interested in the relationship between two variables? For example, you might want to see if there's a correlation between hours of study and exam scores. In this case, you'd turn to correlation analysis, which measures the strength and direction of the relationship. And if you're feeling really ambitious and want to predict one variable based on another, That's where regression analysis comes in. Remember, choosing the right statistical tool is crucial for getting accurate and meaningful results. Think about your research question and the type of data you have. We're almost ready to unleash the power of statistical analysis on our data, but first, we need to pause and read the fine print. Just like signing a contract, it's crucial to understand the terms and conditions before proceeding. You see, most statistical tests come with a set of assumptions, conditions that must be met for the test to produce reliable results. Think of them as the safety regulations for our statistical tools. Ignore them, and you risk getting inaccurate or even misleading results. One common assumption is normality, which means the data should follow a bell-shaped curve. Many statistical tests like the t-test and ANOVA rely on this assumption. If your data doesn't follow a normal distribution, you might need to transform it or choose a different test. Another important assumption is homogeneity of variance, which means the variability of the data should be similar across groups. Imagine comparing the heights of basketball players and jockeys. The variability within each group would be quite different, violating this assumption. Independence of observations is another crucial assumption, meaning each data point should be independent of the others. For example, if you're surveying students in a classroom, their responses might influence each other, violating this assumption. So how do we check these assumptions? Fortunately, there are statistical tests and graphical methods to help us. For normality, we can use histograms, QQ plots, or tests like the Shapiro-Wilk test. If your data violates one or more assumptions, don't panic. There are often ways to address these issues. Now you might be thinking, this all sounds incredibly complicated. Do I need to be a mathematical genius to do statistical analysis? Fear not, my friend, because we live in an era of powerful software that can do the heavy lifting for us. Think of statistical software as our trusty spaceships, transporting us through the vast galaxies of data with ease. These programs are designed to make statistical analysis more accessible, efficient, and even enjoyable. One popular option is SPSS, or Statistical Package for the Social Sciences, a comprehensive software package used by researchers in various fields. It offers a user-friendly interface and a wide range of statistical tests, making it a great choice for both beginners and experienced analysts. Another widely used software is R, a free and open-source programming language specifically designed for statistical computing and graphics. While it has a steeper learning curve than SPSS, R offers unparalleled flexibility and a vast library of packages for specialized analyses. If you're comfortable with spreadsheets, you can even perform basic statistical analysis in Excel. While it might not have the same depth as SPSS or R, Excel can handle simple tests like t-tests and correlations, making it a convenient option for quick analyses. And let's not forget about Python, another versatile programming language gaining popularity in data science. With libraries like Pandas and scikit-learn, Python offers powerful tools for data manipulation, statistical modeling, and machine learning. No matter which software you choose, the key is to find one that suits your needs and comfort level. Embrace its power, and you'll be amazed at the insights you can uncover from your data. Congratulations! You've just completed a crash course in choosing the right statistical tool. We've covered a lot of ground, from identifying your research question to checking your assumptions, and even harnessing the power of statistical software. Remember, choosing the right statistical tool is like choosing the right telescope to observe the stars. The right tool can reveal hidden patterns, unlock insights, and help you make data-driven decisions. Now you know how to choose the right statistical tool. Try picking the best tool for these scenarios in the comments below. Comparing 3 different diet plans? That's ANOVA. Studying the link between sleep and productivity? That's correlation analysis.